regions of the world. This is an IUPAP UCR project which has been funded by the 2016-2019 ICSU grants project. For what concerns this session, I'd like to introduce my two co-chairs, Jean-Paul Ngome, who is representing UNESCO here, and Sekazi Ntingwa is here, who is representing IUPAP, as well as this project funded by the ICSU grant. We are going to allow each speaker, we also have other speakers on the panel, and I'd like to introduce Maciej Nalec, who is on the left-hand side, who's former director and executive secretary of UNESCO IBSP, and Simon Connell, who is in charge now for the African Light Source Initiative, chair of the steering committee, and Giorgio Paolucci, who is the scientific director of Sesame. So as you see, we would like to focus on the situation of light sources in the developing countries and try to discuss about future developments and initiatives for this. We are going to allow each speaker to give a short talk, and we will keep some time at the end of the session for a question and answer session, so we will not allow questions at the end of each short talk. We prefer to have a round table in the end for some discussion. So I would like to invite Jean-Paul as co-chair of this session to introduce our first speakers.
Thank you very much, Michele. It's a pleasure, as you have mentioned, to be here this morning. I would like to introduce our first speaker. Maciej Nalec is a director at the Polish Academy of Sciences, but before that he was a director of the Basic and Engineering Sciences in UNESCO for more than 10 years, and also the executive secretary of the International Basic Sciences Program of UNESCO. Maciej is probably the living memory of Sesame from a UNESCO's perspective. Maciej, the floor is yours.
Thank you, Jean-Paul, for this nice introduction. To be a living memory means that one has to be in Mathusalemic age, which obviously is the case, but let's go into business. Now, let me say a few words of a kind of introduction to this session, because one has to remember that why are we interested in strong light sources? Because capacity building in science and technology, based on basic sciences, in fact, is something which is far-reaching in terms of producing innovations for society and environment. And this is absolutely vital for development. So, investing into basic sciences and promoting innovations is a sine qua non condition for sustainable development. And UNESCO has here a long tradition. Myself, I witnessed several creations of centers that we call Category 2 centers under UNESCO auspices or international organizations, institutional capacity building, human capacity building. This is what UNESCO is very strong in. Now, the best to exemplify this is the case of CERN. Maybe not all of you know that CERN was created under UNESCO auspices, and it was created after the Second World War and is still an immense success, growing in importance after 60 years of existence. So, taking CERN as an example, we at certain moment started constructing Sesame. Sesame, this is a project for which I was hired to UNESCO. When Director General Mr. Matsura was recruiting a director for basic sciences, it was in the job description having Sesame as the main issue to follow and monitor. Sesame is here in Jordan, so it's a right place to say a few words about it. It was created conceptually on the model of CERN, although of course two organizations are quite different. It has a beauty of being composed of entities politically quite diverse, like you have it in written, like Iran, Israel, Palestinian Authority, Turkey, Pakistan, Cyprus, Egypt. It was not easy to create, but it exists and it is already in operation, and Giorgio Paolucci will tell you how science is done by Sesame. It has also very strong observer states, which is important and helpful to the existence of Sesame. In general, international collaboration is an obvious way for countries with limited science budget. And therefore, constructing strong light sources on an international collaborative way is something that actually helps countries of lower scientific budgets to be able to create such a center. Now, synchrotron has this beauty that it is interdisciplinary, because depending on what type of beamline you actually construct, you can have studies in physics, chemistry, biology, medicine, pharmacology, material sciences, engineering, environment, archaeology, whatever. So by investing into one center, you actually invest in many sciences at the same time. And that's why it is a fantastic tool for development based on science and technology. Short history of Sesame, 2003, groundbreaking ceremony with His Majesty the King Abdullah II. Here is how Sesame looked at soft opening in 2008 when the building was ready. The same moment, this is a building still completely empty hall, which is now full of equipment, already a machine standing there. Director General Matsuura in the center. Sir Chris Llewellyn-Smith opening Sesame during the ceremony in May this year. And a very brief history tells you that actually from the first concept, which was somewhere in the 80s given by Abdus Salam, but actually more concretely proposed in 1997, and one of those who are responsible for the idea of Sesame is with us, Hermann Wienig, was among those who proposed the whole concept. Professor Voss from Germany was the other important inventor of Sesame. Then through many processes, as you see, including UNESCO executive board decisions, general conferences, and so on, it took actually 20 years from an idea to the machine. It is very important to remember that the decision in 2004 was to construct a completely new ring, because Sesame sometimes was considered an old machine based on Bessie 1. That was the original concept, but in fact it is a fully modern third generation machine. Magnets for Sesame has been constructed by CERN, financed by EU, and constructed in collaboration with Sesame. And here you have two important personalities, Herwig Schopper and Chris Llewellyn-Smith, two former director generals of CERN and former presidents of Sesame Council, standing close to one of the magnets produced in CERN. So as I said, Sesame was finally constructed as a state-of-the-art machine, and there were many donations from synchrotron sources, laboratories all around the globe. So really, international community was supporting Sesame from very beginning very strongly. It's a key UNESCO project, not only in terms of capacity building, but also in terms of science for peace in the Middle East. And it shows the strength of science to build bridges between different cultures and society. And the impact of such an activity goes far beyond scientific objectives. Now, what lessons can be drawn from Sesame? Because we are now talking about the concept that similar synchrotrons can be constructed in other parts of the world. There will be a presentation on African life source. There is a lot going on in Latin America, in Asia, in other continents. Now, from my perspective of UNESCO coordinator of Sesame activity, one has to remember a few things. First, the initiative to construct a life source is likely to take much more time than originally envisaged. It was for Sesame 20 years. Of course, if you happen to be in the United States or Japan with unlimited resources, you can construct synchrotron in a few years. We know cases like that, but we are talking about light sources in countries with lower income, where this light source is to stimulate development. And here you need patience, because it may take longer than you originally thought. Second, the country hosting the initiative must be prepared to invest large sums of money, and usually more than planned. It has therefore to be politically stable and fully dedicated. And I can give an example of Jordan, who did a fantastic job for Sesame, but it provided the site and paid for the Sesame building, provided funds for computing infrastructure, cooling system, will fund solar plant, supporting electricity to Sesame. Royal Court provided funds for shielding walls, and so on and so forth. A lot of money, tremendous financial effort. So a country which is to be hosting the next light source has to be prepared that it's going to cost, but something will come out of it, like Sesame, something absolutely fantastic. Now, the third possibly conclusion I can drive from my observations is that it's very important to have strong international support. And for that, international scientific community is not sufficient, although very important, because it is important to have connections to other light sources and so on. But political support from other member states is absolutely vital, and here UNESCO may really help, as it did for Sesame. So I strongly warn my colleagues now in charge of UNESCO program in capacity building to be prepared and help other ideas to construct light sources in the world. Finally, it requires an expertise, and the best is to have an international board of experts, because no country is actually alone in the scientific endeavor. You need help from people who know how to do it and what to do. And of course, the best is if you are able to have leaders of this international board of experts of the caliber renowned internationally, as was the case of Sesame with Professors Herwig Schopper, Chris Llewellyn-Smith, and now Rolf Hoyer, present here in the room. And Rolf, I welcome you very warmly. Thank you for being with us. All former Director General of CERN, who made a great difference for Sesame to exist. Now, it should also be said that a host country must have a leader who is dedicated, enthusiastic, competent, and well-connected. And the best example of this is Professor Khaled Toukan in Jordan, who from very beginning made Sesame possible because of his competence, dedication, and of possibility of going to the royal court and getting right decisions at right moment, and also securing this large financing of Jordan to the machine. Last conclusion that I wanted to share with you, but it is very important, that's why I put it as last, is that the light source that you will construct must be state-of-the-art. It cannot be an old machine. The idea that we started from in Sesame, that will be an old Bessie 1 dismantled in Berlin and reconstructed in Jordan, was politically interesting because from the very beginning it was shown that the international community is helping to create a light source in the Middle East. But scientifically it would have been a disaster because you need to construct the best machines possible. Professor Khaled Toukan came just after I was praising him, so he didn't listen to my words, unfortunately. Remember that a low quality equipment will never result in a needed stimulation of science, technology, and innovation. You have to start high. And if all this has happened, as in the case of Sesame, you have celebrations like this at which you have the Director General of IAEA, the Director General of UNESCO, the European Commissioner, two former directors of CERN, Crystal Welling-Smith and Rolf Hoyer, and somebody who took the place of everybody else because I was making this photo sitting in the second row, and unfortunately he stood up. But I still managed to have a picture of His Majesty here opening. This is a current Director General of CERN, Fabiola Gianotti, and a lot of ministers. So this type of phenomena can really happen. And it doesn't matter, it was after 20 years from the idea. It's a great, great success. Remember that science and technology offers a chance to humanity to turn adversity into opportunity. And we have all to do our best to stimulate sustainable development in less developed countries. And I thank you very much for listening.
Thank you very much, Maciej, for this fantastic journey into the history of Sesame as an example to be replicated in other regions of the world. Now I would like to welcome our next speaker, Giorgio Paolucci, the scientific director of Sesame, who will talk about the opportunity for science and growth in the Middle East. Giorgio.
Good morning, everybody. I would like to thank the organizers for giving me this opportunity to talk about this project, which we are working on a few miles from here. So Sesame, as already said, is an existing laboratory whose idea started a long time ago, but now is coming to reality. So just to remind those of you who are not familiar with Sesame, Sesame is located, as I said, a few miles north from here. Okay, I don't have to stress this point, but it's certainly located in a part of the world that you normally listen to the news for other reasons. As already said by a previous speaker, it is an example of science diplomacy in the sense that it puts together members which normally do not talk to each other, to say the least. And from the organizational point of view, as it was said, it's a sort of CERN of the Middle East, although the scope of the project is different, in the sense that synchrotron radiation is a very, very versatile instrument which is used for pure and applied science. It's used for studying materials. It's used to study archaeological artifacts. So it's a very broad range of applications. And this is what makes a synchrotron an ideal place in any country or in any location to establish connections, not only from the political point of view, as you can see here, but also the scientific point of view. I always say, you know, a synchrotron is something which is the exact opposite of a university department. In a department, in any university, you find physicists, only physicists, or you find chemists or biologists. In a synchrotron, you find everybody, and they are forced somehow to work together. And that is something which is in the very nature of a synchrotron radiation laboratory, and which helps a lot establishing dialogue. Moreover, in the idea of setting up such a laboratory in this part of the world, there were ideas about fostering excellence, fostering technological development, reversing the brain drain, and of course, together with the contribution to mutual understanding. For this reason, the project attracted the attention of a number of observers, which are listed on the slide, which have contributed in various ways to the project, and I'll show some examples about that. I said before, the original idea was to rebuild a used accelerator. So that is again, if you wish, a meeting or an occasion in which science and politics meet, because Germany decided to build a new synchrotron radiation laboratory as a consequence of the fall of the Berlin Wall. So that was how Germany decided to build a new machine and made this ring available to others. And as I said before, Hermann Winnig and Voss had the idea of taking this to the Middle East and using it. However, as correctly said before, if you rebuild a synchrotron, an old synchrotron, now just to give you the frames, the time frame of this thing, the Bessie 1 synchrotron started its operation in '81, and I'm old enough to remember the excitement about the first beam in Bessie 1, because I happened to be postdoc in Berlin at the time, so everybody was excited about that. If it started in '81, of course, it was a machine conceived in the '70s. And as I said, we want to foster high-tech, innovation, science, and you want to reverse the brain drain. And you don't attract a Jordanian scientist, for example, who is a postdoc in the States, offering him or her a 40-year-old machine. So the project developed. There were some proposals. Oops. There were some proposals of updating the machine. And then the idea was, okay, we use what we can of the BESSY one machine, and we build a new accelerator. So this is what Sesame looks like. This small ring here is basically the reconstruction of BESSY 1. Everything else is brand new. The energy was increased, because if you increase the energy of the electrons, you get better performance in terms of short wavelength emission. You open up a number of techniques. And so this is what the project looks like. And I will jump a few decades, a couple of decades, as said before, and we go directly to last year, when the installation of the new machine started. And here you see a typical picture of what you see every day in Sesame, which is a cooperation between local staff, engineers, and technicians, together with people coming from CERN to help us to install the machine, align it properly. So this is a sector of the machine with the magnets which were basically supported by the European Union. This is another part of the machine, which is an in-kind contribution from one of the observer countries, Italy in this case, which offered the construction of the 4 accelerating cavities which are needed to give the energy to the electrons, because the idea is that you have electrons circulating, they lose energy, you have to give the energy back, and this is done by these devices. I apologize for the quality of the picture, but I took it personally with my mobile, so it's not very professional, but it gives you an idea of the complexity of the installation. This year, we moved from the first idea, then construction phase, we moved into the operational phase. In the first months of this year, we reached good working conditions for the storage ring. And now we are operating reliably with a relatively high current. We managed to inject regularly at 60 milliamps. The target value is higher, is about a factor 3 higher than that, but that needs time, because but we managed to inject even higher than that. But routinely we can get the 60 milliamps. The lifetime is increasing, so the beam is stable over several hours, which allows us to start doing the commissioning of the what we call beam lines. The beam line, for those of you who are not in the field, are basically stainless steel pipes which depart from the accelerator, which collect the radiation emitted by the electrons, and then are used for different purposes. We start with, I will describe the first 4 of them with some details. Two of the first 4, as you can see, are reinstallation of donated equipment. One is the XRF beam line, which was donated by the Helmholtz-Zentrum Dresden-Rosserdorf. It was installed at the European Synchronization Facility in Grenoble. The other one is the material science beam line, which was installed at a Swiss light source near Zurich. However, as said before, so these 2 beam lines are relatively new, and it makes sense to reinstall them. But as correctly said before by a previous speaker, you need to provide the users who want to come and use this facility with modern instrumentation. Therefore, the other 2 beam lines are new. One is the infrared beam line, which is being built together with the Soleil synchrotron near Paris, and we happen to have in the audience Dr. Jian Kamel from Egypt, who is the beamline scientist in charge of the infrared beamline. So if you have specific questions about infrared, please ask her. And the micromolecular crystallography beamline, which is under construction, which is also going to be new. We changed a bit the original plan, which was the reinstallation of a beamline from a donation from UK, and we got partial support by the Jordanian Scientific Research Fund. And I will say a few words about it. So these are some pictures showing various phases of the installation. Here you see the installation of one mirror chamber, and you see one of our engineers who also happens to be in the audience. Thayer is over there. You see he was very happy that day, because when you see things which are becoming reality, you always get emotional. And so, and these are the two technicians, the engineer and technician, working on the monochromator, or the same beamline, reinstalling and understanding the various motions which you need to bring the beam from the source to the end. This is experimental station. The XRF beamline can be used for a number of things. One of them, I'm just showing one example, which is the use of XAFs for environmental science. The beamline scientist of this beamline was involved in a IAA-supported project to study soil contamination, and he did everything from getting the soil sample to measuring them. And here you can see what kind of information you get. You can set the concentration of chromium-5 to chromium-4, and you get a concentration of zinc from soil, and from that you can understand what is the source of contamination of your soil, as an example. The infrared beamline, as I said, is under construction. This is a picture of Paul Dumas from Soleil and Gian in the machine tunnel during the installation phase a couple of months ago. We are in a good state with this. The infrared has an advantage that the infrared microscope we have is also an conventional source, which allowed us to start doing some research. This is an example of experiment which was done by a user from Pakistan. As you can see, again, a very applied science, study of breast cancer tissues. And I was supported by her travel to Sesame was supported by the Lansbury Foundation. These are other papers produced with our instrument. I see that my time is finishing. So just a few words about the material science beamline. This is the source. It's a Wiggler source, which was donated by Switzerland, as I said. This is the type of flux. And the macromolecular crystallography is, as I said, supported by the Jordanian Scientific Research Support Fund. And the approval is for a financial support of 1.5 million Jordanian dinars, which corresponds more or less to $2.1 million. And the first part of the beamline is being bought this year. We wrote the technical specs of the vacuum modulator, which is a very sophisticated device, together with the help of friends from Max 4. And the call for tender is published on our website, and so we will contract this during this year. So. We had a first call for proposal, just 2 minutes. I know I spoke for 15 minutes, 37 seconds. We have a first call for a proposal this year. We received a lot of interest from various countries. You see here the number. In this particular case, the country identifies the origin of the institution. It's not the national, no, it's not the nationality. So, for example, the proposal for Colombia is actually from an Italian scientist, just to, anyway. But you can see that we got a lot of interest from the region. We have 55 proposals, which was a good success. And the proposals now being analyzed by our review panel, which is shown here. And in the coming weeks, we talked with Samar 2 days ago. We will communicate the results of the review process. Just a few words about your involvement of Europe. We have a project which is called Open Sesame, which, as you can see, brings again to Sesame the experience of existing sources. And it has various work packages which go from training of our staff to training of prospective users to communication. Last but not least, as mentioned before, we have further help from EU for a solar power plant for which will be 6 megawatt, which will make Sesame the first synchrotron lab fully running with renewable energy. So, at the end, Sesame, as said before in various forms, will provide the region with unique research infrastructure, will foster basic applied research, will contribute to the development of new high-tech companies, both by direct application of methods and by applying new techniques. Thank you very much for your attention, and we'll have some discussion after.
So next we will hear from my good colleague, Michele Zema, who is the outreach officer for the International Union of Crystallography and also a professor from the University of Pavia, and he will talk about light sources and crystallographic sciences for developing countries.
Thank you very much, Sekasi. And I'll try to show you some of the projects that we are implementing from the side of the International Union of Crystallography, but all this brought to many collaborations with other unions and bodies and UNESCO. So I want to show you a little bit of background about this. So first of all, just to introduce you what the International Union of Crystallography is. It's not different if I had to introduce any other international union, belonging to ICSU. But if you see at the aims of our scientific union, you will see that the first thing is promote international cooperation in crystallography, in science in general, and in this case specifically for crystallography. How it is structured, we have member countries, quite a high number. We have regional associations, many adhering bodies. We have commissions dealing with all the aspects of crystallography, which, by the way, is a very interdisciplinary field of science. Our community includes scientists from biology, chemistry, material science, physics, mathematics, and so on. The importance of crystallography has been celebrated, in a sense, quite recently in 2014 by the International Year of Crystallography, which was proclaimed by the United Nations and was coordinated and organized by the International Union of Crystallography together with UNESCO and in particular the IBSP Institute. So I had the opportunity, and I was very honored to collaborate with Maciej Nalec and Jean-Paul Gomez and their team in UNESCO to coordinate the activities for IYCR 2014. So I want to say that starting with this, we have tried to tackle the problem of developing science and engaging people and increasing the awareness about the importance of science and crystallography from different aspects. And I want to start with the opening ceremony, the grand opening ceremony that we had in UNESCO, where we had a very important declaration from young, talented crystallographers of the world. And already at that time, we have started putting together some of the main aspects that the people who are in the field are considering as important points, like extreme workloads, access to facilities and journals, training, funding, collaborations. So these things have been in our minds for the organization of all the other activities. And it's quite impossible for me in this very short time to show you all the activities that we have organized during the International Year of Crystallography. I've put just a list of things that happened during the year 2014, like exhibitions, science fairs, and we have a lot of material that we have made available for free for the scientific community. Well, if you see these photos, you really understand how important and how we could engage people and young people in particular. What I want to say is that we have tried to target all different categories of people. So you have seen many very young children in those photos coming from science fairs and activities for them. We have started some activities for school children and school teachers. So we are providing information and material to conduct some scientific experiments in the schools, like this crystal growing competition, which is now at its 4th edition. So there is a continuity of the activities that we have launched during the International Year of Crystallography. So with this, we are targeting a specific group of people, and it was very good that this was done also in collaboration with the UNESCO network of schools in Africa and in the developing countries as well. We have done a lot of activities for increasing the awareness to the general public. I see people who were in Hyderabad for the IUCR Congress who could see this model, which is the largest crystal structure model ever built. It's something like 3 meters age, and it is an installation which gives really huge opportunities for, talking with people, engaging with people. During the International Year, we had some like 100 of activities for school children around this model. Of course, we also wanted to discuss the matter about increasing the awareness and talking about science at the level of science policy. So we have organized summit meetings for the 3 target regions, Latin America, Africa, and Southeast Asia. And these were about, political discussion about how to develop science, so bringing together politicians, influencing people with high-level scientists. And this is probably the project I'm more passionate about, because this is for young scientists and young professors from the developing countries. This is the IUCR UNESCO Open Lab initiative, and what we are doing with this initiative is to open real research centers, so laboratories. We try to work with the manufacturers, with the companies, in order to have instrumentation that they can bring to the developing countries, mainly again Africa, Latin America, Southeast Asia, and provide this instrumentation for free. We organize workshops around this instrumentation, and then we follow these people in order for them to start their own research. So this has been done already. We already had 27 editions in 23 countries, starting in 2014. So this is a very active project that we are conducting. Soon after this meeting, we have an open lab in Senegal, and soon after that, it will be in Costa Rica. So as you see, this is a very active project. And the thing is that even if you are not doing cutting-edge science, you are anyway giving the opportunity to raise the bar and to increase the background, the scientific background in our country. So our mission is to level the scientific background worldwide. So this is, again, the list of all the open labs so far. And we have closed the International Year of Crystallography by actually opening the legacy of the International Year of Crystallography with a conference which was held in Rabat under the title Crystallography for the Next Generation. And I want to show you all the institutions which are listed here on the left-hand side of this slide who have signed this resolution committing to continue building capacity in developing regions of the world and extend further the public understanding of science. So we are committed to do this, and that's why all the activities starting with the International Year of Crystallography are not concluded at all, and we are pushing a lot to continue to maintain the momentum generated by IYCR 2014. So that was a grant that we have received from ICSU in 2015 for building science capacity in Africa via crystallography, and that was a very important project because this gave us the opportunity to organize the first Pan-African conference on crystallography. So that was the first opportunity to gather together scientists from all over Africa to discuss about crystallography in this case, but you know, it's an excuse to put together the community, to make them aware that they have to collaborate. And this follows our Crystallography in Africa initiative, which was launched in 1999. So we have a strong experience in implementing activities in Africa in particular and developing regions in general. We now go to the reason why we have this session here, which is the new ICSU grant that we have received in collaboration, in partnership with IUPAP. So we were very happy to accept the invitation of IUPAP to participate in this project, and that was about the new ICSU grants program, which seeks to facilitate active collaborations between scientific unions. So it's very specific for collaboration between unions, and the aim is developing science education, outreach, and public engagement. So we had this project approved, which goes under the acronym of LAMP, which stands for Light Sources for Africa, the Americas, and Middle East project. Sekazi, who is here sitting close to me, is another member of the executive committee for this project. But I want to show you the full project title, which is Utilization of Light Sources and Crystallographic Sciences to Facilitate the Enhancement of Knowledge and Improve the Economic and Social Conditions in Targeted Regions of the World. This means that we are not trying to focus on the scientific aspects only, but we want to open a debate about the fact that improving the scientific instrumentation will help growing a community which is more aware about the possibilities of collaboration and raise the bar again of the scientific background worldwide. So as I said, the lead applicants are IUPAP and IUCR, but we have a number of partners. Main partner, of course, is UNESCO, and this is the grant awarded for a 3-year period. So this is the executive committee at the moment. So it's me, Sekazi, Sandro Scandalo, who is not here today. And just quickly, I want to show you the main tasks. So we want to develop a strategic plan for each region. We want to establish a colloquium program. We are preparing an information brochure about the importance of light sources. And we are also promoting mobility of researchers from developing countries to visit the facilities and get experience on that. In the end, there will be, to close the project, there will be a meeting at UNESCO in December 2019. And this is my last slide. So this is the call which is open at the moment, although the deadline is very close, it's the 15th of November. But this is to show you that we are providing grants for teams of faculty members and PhD students to travel together and spend a 2-month period in a facility in order to get trained about the use of the facility. So this call is open now. There will be another call next year. So it is important that everyone spread the news about this, because this is an actual opportunity for people in the developing countries to learn about all this. I know I'm a bit late, so I stop here and thank you very much for your attention.
Yes, yes. So next we will hear from Jean-Paul Ngome Abiaga from the Basic Sciences Program from UNESCO, who will share with us opportunities provided by light sources in developing countries.
Thank you very much, Sekazi, for the introduction. It's a great pleasure to be with you this morning. I'm repeating myself. I have joined UNESCO 6 years ago with the belief that science and education can really reverse underdevelopment. And I am still feeling that this is possible, and being in an organization like UNESCO makes me feel more and more grateful. And I would like to share with you another belief of mine, which is that light sources are really opportunities to really help developing countries to move forward and to reach the sustainable development goal that we are all expecting by 2030. A quick presentation on UNESCO. UNESCO was constructed in 1945, just after the Second World War, with a motto which is that science, which is that since wars begin in the minds of men and women, it is in the minds of men and women that the defenses of peace must be constructed. And this preamble of the constitution of the organization is still alive. We do think that we can really make the difference by changing the mindset of men and women of this world. And in that sense, science has been playing a huge role in trying to move forward this objective that we do have. And it was introduced by Machi, all the different milestones that the organization has succeeded to meet in creating organizations like CERN, like ICTP, TUAS and Sesame. We spoke a lot about Sesame this morning, but also the International Basic Sciences Program in 2004, the International Year of Crystallography, but also the International Year of Light. And quite recently, just 2 years ago, we have been parting in the setting up of 17 Sustainable Development Goals, which we really think that will make the difference in the years to come and to help developing countries. I would like to start with a quote from Einstein, which says that peace is not merely the absence of war, but the presence of justice, law, and order, which, in my opinion, mean that there are a lot of different ingredients that we can put together to really help people to live in a peaceful world. Of course, not in the absence of war, because this is almost impossible, but at least to allow men and women of this planet to live, to benefit from the outcome of science, education, and to really live together as much peaceful as possible. And this led us to one of the huge achievements of the organization, which is Sesame. As it was mentioned this morning, Sesame has taken more than 20 years to be constructed and to be fully operational as it is nowadays, with the launch which was held in May last. But we think that it goes beyond science, as it was mentioned already. I mean, when you have these people coming from different countries which are not in a very good relationship, working together, doing research together, collaborating together, then you see that science is a real bridge. Science really helps people to overcome difficulties. But as a Latin American proverb says, only one hand cannot hide the sun. And that's also the feeling which is shared by all the speakers here on the fact that actually the world needs more light sources. As you can see on that map, there are huge regions which are lacking light sources. We have Africa, Latin America with only one, Southeast Asia, which shows that we still have a long way to get those regions equipped scientifically and to be able to conduct real research, interesting research and very important research. That is very important if we really would like to construct a world which is more peaceful, because science, and a good science, has his role to play on that. If you look at the UNESCO Science Report, you will see that the map which I've just shown before corresponds exactly with the situation of science in general in the world. You will, on the graph, you see different figures which are about the number of researchers in some region of the world, the number of scientific publications, the investment in research and development, and we see that there is a huge divide between the North and the global South, which needs to be addressed properly. And I think that this is also what the light sources can bring to this planet, how light source can really help those regions to improve their scientific publication, to increase the number of scientific publication, to help to increase the collaboration between researchers coming from one region to another, from one country to another, sitting together and doing good science. And again, I'm repeating myself, but this is a belief that I have, that light sources contribute to sustainable development. They are contributing to the development of critical mass of researchers, as we see now in the Middle East with this growing number of users. And it's clear that Africa and Latin America and Southeast Asia should be part of this global trend, which is to make available, to give access to science, to basic sciences in particular. It helps also to develop regional international collaboration. It has been mentioned this morning. It is very important to really help those countries which are lagging in science to collaborate, to sit down together. And this is, light sources are really a facilitator of that thing, because we all know that it is very expensive to set up light sources. We all know that it is very difficult. It took 20 years for Sesame, as mentioned by Matthew this morning. So actually, at the end of the day, it's a good thing, because then it helps countries to sit down together, to work together, to at least set up a kind of shared science policy, and at the end of the day, to contribute to the Sustainable Development Goals. And light sources also improve education and create opportunities. I think that's one of the main points which I would like to raise this morning: opportunities. That's what is missing in Africa, in my continent. I remember when I was young, how difficult it was to go to church. And I think that this is a question which needs to be addressed properly. How do we give opportunities to youngsters in Africa, maybe less in Latin America, but in Southeast Asia? How do we give them the opportunity to do science, to do good science, to be involved in the global community of researchers when they start their research? And light sources also contribute to reduce the divide that we see between the North and the South. I mean, does it make sense for a researcher from Algeria or Tunisia to go to France to do to have access to light sources, because there is none in Africa, there is none in the country next to theirs, and we all know the difficulties it generates, especially in terms of mobility, visas, and so on and so forth. And also, light sources really reinforce knowledge-based policy making in countries. This was underlined already this morning, and this should be really promoted among our governments, that they should have long-term plans, and not just doing small things, few things, but have a kind of vision on what they would like to achieve by 2030, because that's a global framework in terms of science and education and so on and so forth. It was also mentioned this morning by Michele that the International of Crystallography allowed really to promote light, sciences in general, but I think one of the objectives behind was to trigger an interest into science, to trigger an interest into what science can really bring to countries which are lagging. And I think that the International Year of Crystallography was one of these opportunities, together with the International Year of Light in 2015, which really helped to pass the message, to show that science is important, that basic science can really play a huge role, can make the difference in the years to come. And several activities were mentioned, like the Open Lab, the crystal growing competition, and so on and so forth. But I would like to say something. We have an agenda, the 2030 Agenda for Sustainable Development, and science is very important. Science can really make the difference, but not just science for science, but I mean good science. Quality science can really make the difference, can really help countries to reach those goals. It was mentioned this morning that Sesame is first and foremost about science, and then it contributes to peace and sustainable development. But I think that's a key point. We should not construct light sources or invest in the science of 20 years ago just because we would like to copy what is being done in other regions, but we really need to invest into good material, into good equipment, because I mean that's just the trend of science nowadays. And the last point I would like to underline this morning is cooperation. Cooperation, we all know that it is important. We all know that without cooperation, Sesame wouldn't have been possible. And it gives us a very interesting example that we can replicate in other regions of the world. Africa needs to cooperate among itself. I mean, the countries should sit down together and have a common policy. I mean, they have started already with the 2063 agenda, but I think it should be made clear that without having shared equipment, I mean, because they are costly, without having common goals, it is impossible. And the same in other regions of the world. And to finish, I would like to mention an African proverb which says, if you want to go fast, go alone. But if you want to go far, then go together. And that's very important because I think that quotation, that proverb sums up what we would like to achieve together, UNESCO, the International Union of Crystallography, IUPAP, and all the different partners, because we believe in the fact that light source can really change the way science is being done in Africa. We really believe that the basic sciences in general is the way to go to achieve the 2030 Agenda for Sustainable Development. Thank you very much.
Thank you very much, Jean-Paul. And I'd like to introduce our next speaker now. It's very difficult to introduce Akazi because he has so many hats, I don't know. But he's an MIT retired scientist and he's now principal partner at Three-Seed Consultant. I just want to mention some of the roles that brought him here. He is, of course, a member of the LAMP project, the project which is funding this session. He's also a member of the Commission for Development of IUPAP and is, I think, ingoing chair from next year. And he's also co-chair of the steering committee for the African Light Source. So he has a lot of experience of projects in Africa, and he's going to show us some of them.
Okay, great, thank you. Thank you, Michele. First, I'd like to say that I should be a little bit ashamed of myself because I've been promoting light sources all over the U.S. And all over the world, and I'm actually a high energy and accelerator physicist. And you know, in the US, they started shutting down all of our high energy machines. And so I've sort of turned traitor in terms of promoting light sources, because at first, when the money started drying up for high energy physics experiments, I used to cry but you can only cry so long. And so I started saying, well, let me just look into these light sources. What are these things that they're taking our accelerators and doing? And I started learning about all the tremendous revolutions in so many fields. So I've become a big ambassador for light sources. So I spent a lot of time in the US connecting faculty from less known universities to the big facilities. And I've worked very closely with Herman Winnick. And Herman, could you stand, because your name has come up a number of times and you're so humble. People don't know who Herman Winnick is a lot of times, but yes, give him a hand. So I really appreciate the work with Herman. Okay, so let me try to, I will try to shorten mine because we're running a little bit late on time, but I have been working in Africa for some time now, since around 2001, because when I started getting interested in light sources, I said we need to start trying to convince African governments to construct light sources. And so I got involved with some of my colleagues, especially in South Africa, and I was actually told that that may be a bit of a leap. The first thing we need to do is to improve laser science in South Africa. So what we did was start an organization called the African Laser Center. We started planning for this around '01. We officially launched this in 2003 at a conference that was held in South Africa among ministers of science. So this is a nonprofit organization that's headquartered in Pretoria, South Africa, and we have over 30 labs across the continent who are involved. And we give grants and other types we sponsor workshops, conferences, a lot of things. But we were the first organization to call for an African multinational synchrotron light source, and that's a part of our strategy and business plan that was written in 2002. So here's a map that shows you the location all over the continent of places where we have institutions and laboratories involved in the African Laser Center. Our principal objectives are to promote research and training in laser optics and photonics, promote and foster technological innovation involving lasers. This is an important one in reversing the brain drain on the continent, and to improve the quality of life for all African peoples. So some of the programs, I think I jumped too much. Okay, so some of the programs, we have grants that we give to researchers, and what we try to do is to have a lot of travel and mobility so that researchers are collaborating between countries. And in fact, when I leave here on Sunday, I go to South Africa and sit on a review panel to choose grants for the next year. We have sponsored a number of student workshops. An important thing is training for laser technicians, because when the laser equipment breaks or whatever, we want people who have the training to be able to repair the equipment without having to wait so long to ship equipment overseas to bring it back. We have equipment loans, laser loans, and part of this comes from South Africa's involvement with France. They had a uranium enrichment program using laser technology, and that program closed, and South Africa was left with a lot of state-of-the-art laser equipment, which has been used for loans, and we give equipment donations and so forth. I've mentioned this. Let me just move on. Okay, so at the founding ceremony, these are the people who actually were involved in founding the African Laser Center. At that same day, later in the afternoon, after that ministerial conference, we had this was the next day, we had a business meeting. And it's important to point out this gentleman here, Philemon Mjwaha, who is the Director General of South Africa. In fact, he's the person who works very closely with Minister Pandor, who's at this meeting, and has led the charge for South Africa getting the square kilometer array, winning that bid. But I had the great pleasure back in 2001 to work very closely with Philemon in starting the African Laser Center. So it's nice to know people before they become famous, and hope they remember you once they become famous. Okay, let me skip that. I will skip that one. So this shows you some of the student workshops that we have had, training students to use lasers, and some other meetings that we've had. One of the very nice things that we've sponsored were these U.S. Africa Advanced Studies Institutes, where we have brought professors and graduate students from the U.S. to Africa and brought professors and students from all over Africa together to talk about the latest advances in laser science and technology. And this one was held at Itimba Labs, which is outside Cape Town in South Africa. Here's another one that we held in Egypt. That was a very nice, and you can see us enjoying ourselves. You have to put some social in, right, with the science. In fact, there's a lot of science in this structure here. Okay, some of the outputs. I will just point to a couple of them. The number of students, and this is between 2006 and 2012, the number of students that were trained or involved in some of these conferences and workshops is on the order of 1,000. So by now it's maybe on the order of 2,000 students that we've been able to help, to spark their interest in lasers. And we've supported a number of PhD students. So many, I'm very excited about what we've been able to do, because we want to lay the groundwork with optics and lasers in order to leapfrog into the whole light source business with the big synchrotron facilities. I'll skip this one, but just to say briefly, we've had contributions from, what did I do? Because I'm coming down near the end. Well, let me just scroll through it quickly. Okay, we've had contributions from Algeria, so many countries, Zimbabwe, Botswana, and so forth. And with that, I say thank you. So this was a nice way to get me involved in doing something in Africa. And I must say that originally, one of the persons who inspired me the most to get involved with Africa is Abdus Salam, Nobel winner Abdus Salam. So with that, I say thank you. Okay, oh yes, you have to introduce. Okay, yes. Okay, so our final presentation will be my colleague Simon Connell from the University of Johannesburg, and he will talk to you about the African Light Source Initiative.
Are you going to put my... While my presentation is coming up, I'll say how happy I am to be here. I felt unexpectedly at home in Jordan, and I don't know why. I'm really happy to be here. Now, I'm the only African, I think, on our panel. You're African? Okay. Right. So a lot of the things that I put in my slides have been said, and I'm going to go a little bit faster, but I want to also tell you maybe the perspective from an African point of view. When I look at this slide, I see everything in the north, and of course we've heard about the divide, but I also want to say there's a thing called the African science diaspora, and there's still a lot of Africans involved in this science here. So Jean-Paul, in your slide where you say there's very little publications coming out of Africa, I think you can correct it if you can find data when Africans were participating from other countries, because that's one finding on the roadmap to the African light source is unbeknown to us. Because of the African science diaspora, there are a lot of very, very good African scientists working at these other synchrotrons. But what's interesting about this picture is not only what it's like now, but you can add onto this picture 14 major upgrades or new builds. So it hasn't stopped at the red dots that you saw in the previous picture. It's going on and at an ever increasing pace. And I think that shows that it's not doing a 10-year-old technology or something. If we were to go for a light source in Africa, it's something that's really very relevant now. And so I just want to say Africa is on a roadmap towards a light source. And I also want to say it's not new. The conversation about this roadmap to the African light source is decades old. I have a collection of emails that show many, many people within Africa, around the world, talking about the African light source. And we already know what it is. It's this premier research tool. And what's it going to do for Africa? Here's a list. And I just want to say there's a lot of stuff on my slides. So I'm actually hoping that I uploaded it on the World Science Forum website, but I don't see how anyone gets to look at it. So I really hope the World Science Forum organizers somehow make the slides available. Okay, and we've seen that the the light source is very multidisciplinary. And I had a lot of things to show here, but just very briefly, the graph on the right shows an ever-increasing interest in research generated at light sources. The slope is not leveling out. And the one on the left shows light sources themselves are getting better and better. And this slide shows light sources address, in this case, biology on many distant scales. So they call it multi-scale. And here's a good news story from research out of Africa. It's actual drug design, improving drugs. And in this case, it's hypertension drugs. And here's another example, water purification by enzymes being made more efficient. So actually, African problems being solved at light sources. What you see here is malaria. What you see here is HIV, another one on HIV. This is energy. I wanted to pause a bit at paleontology. That's the biggest footprint for Africa now in light sources. This slide shows the micro jackhammer. We should not be using it. Instead, we should be taking the fossils to synchrotrons, and they should be scanned there. This one is showing you how you can reconstruct in 3 dimensions to submicron accuracy a fossil that literally went to a synchrotron some months after it was discovered. And what's interesting is they didn't bother to take any rock from this fossil. And they found evidence of a paleo brain in a hominid. In the bottom right, you see the segmentation that's possible. And I wanted to emphasize teeth. Teeth are not fossils. Teeth do not fossilize. Teeth are protected by their enamel. They're preserved in such pristine condition that when you go submicron, you effectively have a kind of a tree ring structure in them. You can date a prepubescent hominid to 1-day resolution. And why that's important is then you can look at brain evolution. So you can have the endocast, and then you can have the date, and you can do very, very important studies like that. So it's revolutionized it. And then this concept of not taking the fossil out the rock. That's a rock on the top left. No one has extracted the fossils. It has been segmented digitally and is a beautiful, beautiful story. You see a therapsid, which is a reptile. It's dug a burrow. The burrow got filled, but it was during winter while the therapsid was hibernating, and a mammal crawled in, knowing that that therapsid's not going to eat it while it's hibernating. It crawled in there and kept warm. That's really amazing. But then there was a flood that entombed them there, and they also found retrospectively, it is like forensic paleontology, that there were some broken ribs on that mammal that maybe made it do that extreme thing. Again, African research. Here you see historical documents from Timbuktu. Here you see rock art. And then what's so spectacular is synchrotrons are improving and the detectors are improving by orders of magnitude, so that you have pictures like this one, which shows a battery shown voxel by voxel in 3 dimensions, and you pick up the internal structure of it with essentially a pair distribution function per voxel. And what I wanted to emphasize here is it's 10 terabytes per day. Nearly all these modalities at light sources, synchrotrons, you are getting terabytes. And so it's a big data exercise. So that was the conversation, that Africa should be involved in that. And then just using the internet, all the people involved in different conversations were collected together and then joined in one email conversation, and then using Google tools, holding an election, launching an interim steering committee, planning for an African light source meeting. At the same time, the African Higher Education Summit was also meeting, and they had a declaration and an action plan, and I want to emphasize Article 532 on page 22. It recommends establishing a synchrotron as a centralized African scientific facility. So we'll say that's probably what we can take now as the very first official statement. The document is on the right there, and you can download it. Then we had our African Light Source workshop. There were people who arrived at that workshop who said to us that it's too early to hold because there's not enough Africans working at light sources. What we found, it boggled our mind. Beautiful talk after beautiful talk of Africans working at light sources. So here you can see Zekazi. Zekazi, if I could just take an opportunity here to thank him for his contribution. Herman Winnick was there as well. There are many other people who should be thanked for their contributions, and they are, if you took time to study the slides carefully, they're all there somehow, okay? That generated a lot of attention in the media, but the finding was that there was a much larger footprint in Africa of synchrotron usage than we had thought, so we were able to audit it to some extent. And that the kind of research that was done was very important to Africa. And this is just a picture of that footprint just in paleontology. So I don't know if anyone believed such a thing would be true, but there it is. You just find a deep penetration of synchrotron-based research into Africa. And not only academic research. We're surprised to find that an industrial petrochemical multinational company originating in South Africa has all these dots in Africa. And that they spent 3 weeks worth of beam time bought commercial rates that they didn't have to publish. That's the extent to which an industry emerged as using a synchrotron. So there's all our discoveries, 8 points. I've basically mentioned them. That just summarizes them. And we came up with these resolutions, which basically said that we definitely need to push forward for a synchrotron in Africa. And this slide collects together some other outcomes, of which I want to mention a steering committee that was now officially mandated to drive a roadmap. And the roadmap's also mentioned there, and the terms of reference of this committee. So they can all be downloaded. And this is what that committee looks like on a world map. And in the roadmap, just to say very, very briefly, it's mostly at the moment about building human capacity, infrastructure, local infrastructure that enables the human capacity that we have built to remain in Africa but still do research at synchrotron, so that there can be a period where the user base grows. That building of capacity extends also to long-term stays, much like we have heard happened at Sesame and also at Brazil's light source, where young people were exported briefly to gain skills, and then workshops, schools, etc. But there's also I think a plan at the level of government and policymakers, and I want to emphasize that because that's got off the ground now, a pan-African governmental program. And one of the things that was a landmark there is just very recently, last month, a specialized technical committee on education, science, and technology in Africa Union. You see there was a presentation by the president of the African Academy of Sciences. His name is Felix Dapara Dokora, and I think you will be hearing a lot more from him in this context. So now what's emerged is there's a partnership, and it's going to find a home in the African Academy of Sciences principally, but there's now a call out, and we'll be driving that call, which is to gain online petitions, letters of support, endorsement, to just build the case of the African light source. And then finally, I want to announce that we will have a second African light source conference and workshop. It's going to be the first week in November, and it will be somewhere in Africa. We will announce that. Thank you.
Thank you. Can you hear me? Yeah? So my name is Louise. I'm a science writer based in Cairo. My question was, I was trying to figure out which other countries were competing to host the Sesame along with Jordan in the first place. And I'd be interested to know also which were the, this is arguments why Jordan was chosen. And the last part, very briefly, is Jordan right now trying to position itself as a scientific powerhouse in the Middle East? And if that's the case, who are the main competitors? Thank you very much.
I think the best is Khaled Tukan to answer this question, the director of Sesame.
Well, thanks for the question. Other countries that were competing with Sesame actually were Turkey, Egypt, Armenia. Actually, Armenia was on board with us at one place. And I think Oman started as a founding father of Sesame. So this was the competition. And it was a series of rounds that took place. The meeting was in CERN. It was, I think, as far as I recall, in 1999. But I can't give you, it was around that time, but I can give you the year exactly. And we sat in a hall in CERN. Herwig Schopper actually was the chair of the interim council, you might say. And then there was a series of voting, starting with these countries, and then it was filtered down to voting between Jordan and then Armenia. And then the final vote went for Jordan. Unfortunately, Armenia dropped out. Oman dropped out, although they joined Sesame at the beginning, but then they dropped out. Now, why was Jordan chosen? Jordan was chosen for several reasons. I would say first, we had basically a competent human resource potential. Also, we had the support on the highest level, the political support at the highest level of His Majesty King Abdullah II. I recall that the letters where countries expressed their interest in Sesame were signed by ministers, typically, or prime ministers, but Jordan's intent letter to join Sesame project at the beginning, before Jordan was hosted, was signed by the king himself. In addition, the reason Jordan was chosen is that it was in the heart of the Middle East. So somebody can fly from Turkey in 2 hours, somebody can fly from Egypt, somebody can fly from Oman. So it was in the heart of the Middle East. Added to that, as science for peace, Jordan was convenient because where Sesame is located, it's very close to the Palestinian Authority and Israel. So indeed, for scientists coming from Israel, they can cross the bridge and reach Sesame within 1 hour and a half. So this is, also was also another important factor as science for peace and science diplomacy. And the site for Sesame in Alan was chosen specifically for that reason, to allow Israeli scientists and scientists coming from Palestine to cross the bridge in an hour. So that's all. What was, you had so many questions, and the last question was? Yes, indeed. Actually, that one reason for the leadership in this country to go for Sesame is that Jordan, as a country with no energy resources, we don't have oil and gas, so we want to invest in our human potential and basically educate, breed, and nurture generations of scientists who would be able to work and compete regionally and internationally. And that's why, actually, in addition to Sesame, this year also we inaugurated the Jordan Research and Training Reactor, which I think some of you have registered and visit tomorrow, as a 5-megawatt research reactor multi-purpose. So yes, we want to place ourselves as a hub in the region with a country with no oil or gas. And definitely we are competing in the Arab world with countries like Egypt, Iran also, but maybe Iran is going in a different direction. And indeed, Israel markets itself as a science hub in this region, and we want also to compete with other countries. But I think Jordan, to be frank, within the now Middle East countries and among the Arab countries, stands in a very good position in the top of the list of countries in the Arab world as a hub for science, with Sesame and the Jordan Research and Training Reactor, to go for advanced science and not just basically, on small-scale facilities, on research reactors, and also the Sesame light source.
Hey, leader. Oh. I'm told by the leader here that we can accept 2 questions. If you could just ask them both, and then we will answer them. Any other questions? Okay, if no more questions, the problem is, the time is solved. Thank you. Let us thank the speakers, please. People want to get the lunch.